Welcome. If you are here, you are probably ready to stop. Stop thinking about what happened today. Stop planning what needs to happen tomorrow. Stop the quiet running list in the back of your mind that never quite switches off on its own. This is Eyes Closed, a place where we slow everything down, together with stories. Not dramatic stories, not stories that ask anything of you, just long, gentle, interesting stories about ordinary things. So here is what I would like you to do right now. Find your position, the one you actually sleep in, not the polite sitting up position, but the real one. Pull the blanket up if you have one. Let your shoulders drop away from your ears. Take one slow breath in through your nose and let it out slowly through your mouth. You don't need to do anything with your hands, just let them rest. You are not going to miss anything important. The story will keep going, and I will keep talking. All you have to do is listen, or not listen, or somewhere in between, which is the best place to be. Let the day go. It was what it was. Tomorrow is not here yet. Right now, there's only this, your breath, this voice, and a story that is about to begin. Are you ready? Then let's begin. Somewhere beneath the floor of the room you're in, or just outside the nearest lawn, there is soil. It may be far down, under concrete and pipes and foundations, or it may be just below a thin layer of loam, or beneath a window box of herbs on a ledge, or a few centimeters under a garden you walk past each morning. You probably walked on soil today, or near it, without giving it a thought. Soil is not glamorous. It is the thing on the bottom of our shoes, the thing you brush from vegetables before cooking them, the thing gardeners get under their fingernails and children get on their knees. But a teaspoon of healthy soil, a single teaspoon, less than a thumbnail's worth, contains more living organisms than there are human beings on earth. A teaspoon. Tonight, we are going to go into the teaspoon, into the vast, dark, ancient, living world that is always just beneath our feet, and that makes almost everything we eat and much of the air we breathe possible. It is a quiet world. It works slowly. It doesn't ask to be noticed. Let's notice it tonight. Settle into wherever you are resting. Take a slow breath and let's go down. Soil is not dirt. Dirt is what you find on the floor. Dust, debris, particles that have come loose from somewhere and landed and somewhere they don't belong. Dirt is displaced. Dirt is out of place. Soil is something else entirely. Soil is a living system, a complex, structured, ancient collaboration between rock and water and air and life, built up over thousands or millions of years and absolutely irreplaceable. What is in soil? Mineral particles, first of all. They are the remains of rocks broken down over geological time by weathering, the slow action of water and ice and temperature change and wind and the acids produced by living organisms. Different soils have different mineral compositions depending on what rock lay beneath them. Sandy soils from sandstone, clay soils from clay-rich rock, the dark, rich soil of the Great Plains from ancient deep rock and millennia of biological accumulation. Organic matter, the remains of living things, dead leaves, plant roots, the bodies of animals and insects, fungal threads, the waste products of a billion organisms. This organic matter, broken down by decomposers, becomes humus, the dark, rich, sweet-smelling component of fertile soil that makes it feel alive in your hands, because it is. Water held in the spaces between particles, air in the larger spaces. The balance of water and air in soil is critical. Too much water and the air is displaced and root systems drown. Too little and the organisms that make soil alive begin to die. And life, enormous amounts of life. A teaspoon of healthy soil contains somewhere between 100 million and 1 billion bacteria. This number is almost impossible to picture. A billion bacteria in a teaspoon. If each one were the size of a grain of rice, a teaspoon of soil would contain enough bacteria to fill several large buildings. But bacteria are not the size of a grain of rice. They are among the smallest living things we know, typically a few micrometers long. A micrometer is 1/1,000,000th of a meter. Thousands of bacteria, lined end to end, would span the width of a human hair. At this scale, a teaspoon of soil is an entire world. These bacteria are not all the same species. A single teaspoon of soil may contain thousands of different bacterial species, and some named and studied, many still unknown to science. They do different things. Some fix nitrogen into the air, taking inert nitrogen gas and converting it into forms that plants can absorb and use for growth. This nitrogen fixation is fundamental to the fertility of soil. Without it, most plants could not grow. Some bacteria decompose organic matter, breaking down dead leaves and roots and bodies into simpler compounds. Some produce antibiotics, chemicals that kill competitor bacteria. Penicillin, the antibiotic that has saved more lives than perhaps any other medical discovery, was developed from a mold that produces it naturally in soil as a defense against bacterial competitors. Many of our most important antibiotics came from soil organisms. Streptomycin, tetracycline, vancomycin. The soil is a pharmaceutical library, and we have only read a few pages of it. Beneath a forest floor, there is a network. You might have heard of it, called the Wood Wide Web, a name coined by a scientist in the 1990s to describe the fungal networks that connect the root systems of trees. It is a more complex and contested subject than popular accounts sometimes suggest, but the basic facts are extraordinary enough. Fungi, the organisms that produce mushrooms as their fruiting bodies, spend most of their existence as a mycelium, thin, thread-like filaments called hyphae, branching and spreading through soil and wood. Mycelium is not like a plant or an animal. It has no defined shape. It grows by extension, sending hyphae into new territory, digesting what it encounters. In forest soil, mycelium permeates almost everything. A cubic centimetre of healthy forest soil may contain several kilometers of fungal hyphae. All those thread-like filaments laid end to end. A particularly important category of soil fungi are mycorrhizal fungi, fungi that form partnerships with plant roots. The fungal hyphae connects to the roots of the trees and plants, and what follows is an exchange. The plant provides sugars to the fungus, which the fungus cannot produce itself. The fungus provides the plant with water and nutrients, particularly phosphorus, which the fungal hyphae can access in pockets of soil too small for root hairs to reach. This partnership is ancient. The earliest land plants, when they colonized land from the sea, perhaps 450 million years ago, almost certainly did so with the help of mycorrhizal fungi. The fungi are thought to have been essential to the ability of plants to survive in the nutrient-poor soils of early land. The mushroom you find in a forest or a field is a brief surface expression of something vast and slow and old beneath it. Most of the fungus is underground. Most of the living world is underground and slow and visible and doing the essential work that makes everything above it possible. Charles Darwin spent 40 years studying earthworms. The same Charles Darwin who developed the theory of evolution, who sailed on the Beagle, who thought about the origin of species for 20 years before publishing. This man also spent 4 decades observing earthworms. His last scientific book, published in 1881, the year before he died, was called The Formation of Vegetable Mold Through the Action of Worms with Observations on Their Habits. It was a bestseller. Darwin understood that earthworms were doing something fundamental, that their constant movement through the soil, ingesting soil at the front, casting it out the back, tunneling and burrowing, was transforming the land all the time. He calculated that in a single year, earthworms in a typical English field turned over tens of tons of soil per hectare. He observed that ancient ruins, stone pavements, old foundations slowly sank into the earth over centuries, drawn down by the constant actions of worms below them. Not dramatically, a millimetre at a time, a decade at a time, the worms working below. The earthworm's role in soil is multiple and essential. The tunnel it creates allows air and water to penetrate soil more deeply. The soil it passes through its body is mixed, aerated, and enriched. Worm casting, the material that passes through the earthworm's digestive system, is among the most fertile soil embedment available. The earthworm breaks down organic matter and incorporates it into the mineral soil, building the deep fertility that makes land productive for farming. A healthy pasture in England might have 1 million earthworms per hectare, working quietly, constantly, turning the soil in their slow, earthbound way. Darwin, watching them, understood something that is easy to miss, that the great transformations of the natural world are often slow and quiet and done by small things working continuously, and that the result accumulate over time into something vast. Soil does not form quickly. It forms at a rate of roughly 1 centimetre per 100 years. Some estimates are more generous, some less, depending on the rock type and the climate and the biological community present. But the general truth is this: the topsoil of a fertile field may represent thousands of years of accumulation. Rock is broken down by withering. Glaciers grind rock into fine particles as they move. Water freezes and cracks and expands, shattering rock. Wind carries particles and drops them elsewhere. Lichens, the flat, crusty organisms that grow on bare rock, produce mild acids that dissolve rock surfaces, releasing mineral nutrients and beginning the long process of soil formation. As particles accumulate, pioneer plants take hold. Mosses, grasses, small flowering plants, their roots break rock further. When they die, their organic matter adds to the accumulating layer. Bacteria and fungi colonize. Insects and worms arrive. Each layer of life adds more material, more organic matter, more complexity. Over decades, over centuries, the community becomes richer. The soil deepens. The deep, black Paria soil of the American Midwest, some of the most fertile land in the world, took 10,000 years to form. The mixed grass prairies that built those soils covered the land from the end of the last ice age, building biological richness slowly, millimetre by millimetre. They were plowed under a few decades in the 19th century. The Dust Bowl of the 1930s, the great disaster in which the topsoil of millions of acres of American plains blew away in enormous dark clouds, turning day into night, in cities 1,000 miles away, forcing hundreds of thousands of farming families from their land, was a consequence of plowing soils that took 10,000 years to build, in ways that left them exposed to wind. 10,000 years, built and lost in decades. Soil teaches patience. Soil teaches that some things cannot be rushed, and some losses cannot be undone in a human timescale. There is a word for the smell of rain on dry earth: petrichor. It comes from Greek petra, rock, and ichor, the fluid said to flow through the veins of the gods in Greek mythology. Petrichor is the smell of geosmin, a chemical compound produced by a type of soil bacteria called Streptomyces. These bacteria are extraordinarily common in soil. As they decompose organic matter, they produce geosmin as a byproduct. When raindrops fall on dry soil, the impact traps tiny bubbles of air that then burst, releasing aerosol droplets into the air. These droplets carry geosmin with them, and geosmin, when it reaches the human nose, triggers the smell we know as petrichor, the smell of rain. It is technically the smell of soil bacteria released into the air by raindrops, and humans are extraordinarily sensitive to it. We can detect geosmin at concentrations of a few parts per trillion. We are more sensitive to this compound than almost any other smell. Why? One theory is that the smell of rain was a crucial signal for our ancient ancestors. Rain on dry land meant water was coming, which meant relief from drought. A sensitivity to that smell might have been life-saving. So, the thing that happens when rain begins, the particular pleasure of that smell, the small physical lifting of something inside when you breathe it in, may be a memory carried in our nervous system from millions of years ago. The smell of soil, of rain, of life continuing. There is a research suggesting that soil bacteria have a mild antidepressant effect on humans. The study of this began as an accidental observation. A cancer patient who received injections of a harmless soil bacterium, Mycobacterium vaccae, as part of an experimental treatment, reported improved mood and quality of life. Researchers investigating this found that M. vaccae stimulated the production of serotonin in the brains of mice. Serotonin is one of the neurotransmitters most associated with mood regulations. Many antidepressant medications work by increasing the availability of serotonin. The working theory is that our immune systems evolved over millions of years alongside soil bacteria. Our immune system expects to encounter these bacteria. When we do encounter them, through working in soil, through gardening, through contact with the earth, the immune system recognizes them as familiar and safe, and something happens in the brain's response to this recognition that it has a mood-lifting effect. Gardeners have well known Anecdotally, that working with soil makes them feel better. The combination of physical activity, contact with nature, and satisfaction of growing things, these are all factors. Perhaps bacteria are also a factor. The earth, in its quiet way, may be taking care of us. So, that is the world inside soil. The billions of bacteria working in a teaspoon. The fungal networks threading through the roots of trees. The earthworms moving through the dark 1 millimetre at a time, turning and aerating and enriching. The rock becoming mineral particles, becoming soil, becoming fertility, becoming food, becoming you. 10,000 years of prairie soil beneath a wheat field. The smell of rain carrying bacterial aerosols to a nervous system that has been waiting for that signal for 1,000,000 years. All of it just below your feet. You don't have to think about any of this, but know that the world beneath you is alive and working, slowly, continuously, in the dark, without needing to be seen. And you can do something like that too, right now. Work slowly, in the dark, without needing to be seen. Let your body do what it knows how to do. Breathe, rest, repair. The earth is doing its work, and you can do yours. And that is where we will leave it tonight. You came here to rest, and I hope that is exactly what you are doing right now, or close to it, somewhere in that warm, quiet place between knowing and not knowing, between the story and sleep. That is the whole point of this. If you made it all the way to the end, or if you are only hearing this now, coming back from somewhere deeper, thank you for being here. It means something that you chose this for your night. There will be another story when you are ready for it. Until then, stay exactly where you are. Let your breathing do what it knows how to do, and sleep well. This is Eyes Closed. Good night.